The three ossicles of the middle ear are the smallest bones in the body and are a crucial structure of the auditory system. The ossicles are the malleus, incus, and stapes. The primary role of the middle ear ossicles is to pick up vibrations from the eardrum and transmit them into the fluid-filled cochlea of the inner ear. However, there is an impedance mismatch between the air in the outer ear and the fluid of the cochlea in the inner ear, because sound travels more efficiently through air than through water. Impedance is the amount of resistance a signal, in this case sound vibration, encounters. There is a 1 to 4,000 impedance mismatch between the outer and inner ear, which is balanced by the ossicles. Another role of the ossicles is to serve as a mechanical advantage to increase the decibels of sound within the ear for proper hearing. Without the ossicles, 30 decibels of sound would be lost in the middle ear and cause moderate to severe hearing loss. The malleus is the most lateral ossicle and is attached to the tympanic membrane, where it picks up vibrations and relays them to the incus. The malleus is 1.3 times longer than the incus, and so when these two bones articulate, they act like a lever, increasing the decibel level in the middle ear. So when the eardrum moves, the vibrations are amplified. This is called a mechanical advantage, leading to a 1.3 times increase in sound pressure level. The malleus consists of the manubrium, which connects to the tympanic membrane, the neck, anterior process, lateral process, and the head, which articulates with the incus. The incus is suspended in the middle ear. It is the transmission point for vibrations between the malleus and the stapes. The incus consists of the facet that articulates with the head of the malleus, the body, the short process, the long process, and the lenticular process that articulates with the stapes. The stapes is the last of the ossicular chain, ending in the footplate that connects to the oval window, where the inner ear begins. The stapes consists of a head that connects with the lenticular process of the incus, a neck, an anterior crus, and a posterior crus, the anterior being the longer of the two, and a footplate that connects to the oval window. A good way to visualize the role of the ossicular chain mentally is to use a stereo as an example. The function of a stereo producing music and the ossicles producing vibrations is actually very similar. The arm of the malleus picks up vibrations from the tympanic membrane. Selective frequencies are amplified, the signal is adjusted per decibels in impedance, and then transmitted to the cochlea. In the stereo system, the arm of the record player is like the malleus. It picks up the signal off the record, or eardrum, which is transferred to the stereo, where the signal is amplified so we can hear it, and certain frequencies are boosted or cut for optimal audition. The signal is then sent to the speakers, where like the middle ear, there must be an impedance match. These speakers have a resistance of 4 ohms, and if they aren't matched for the right ohm rating, you will have significant problems, just like if impedance wasn't matched correctly in the middle ear. The greatest sound pressure level increase in the middle ear comes from the ratio of the size of the eardrum to the oval window. The eardrum is 17 times larger than the oval window on average, giving it a 17 times larger decibel level increase in the middle ear. There is also a 1.3 times increase of decibels between the incus and the malleus because the malleus is 1.3 times longer. So if we take those two figures, the 17 times increase and 1.3 times increase, we can conclude that there is around a 22 decibel level increase from the middle ear.